Hello and welcome back to another video. In this problem, we're told that biologists have observed that the chirping rate of crickets of a certain species appears to be related to temperature. And the table shows the chirping rates for various temperatures. First, we're asked to make a scatter plot of the data. So, on our x-axis, we're going to have temperature ranging from 50 to 90. And on the y-axis, we're going to have chirping rates from 20 to 200. So up here, up to 200, and on the x-axis, up to, let's say, 100. These tick marks represent every 25. And these represent every 10. And so what we're going to do is we're going to graph all of these points. So we start at 50, 20. So 1, 2, 3, 4, 5 is our starting point, just a little bit under 25. 55 is at 46, just a little bit under 50. 60 is at 79, so a little bit above 75. 65 is at 91, so right there. 70 is at 113. And we continue to go up. 75 is at 140, just right there. 80 is at 173. 85 is at 198, so right under 200. And 90 itself is at 211, a little bit off the chart. So we're asked to find and graph the regression line. So the LSRL, the least squares regression line, is the line that minimizes the distance between the line and all the points. And you can do this a couple ways. You can do this online. You can do this with your graphing calculator. But the regression line for this particular relation is y is equal to 4.857x minus 220.97. Now, graphing the regression line is not really something that's possible effectively on a hand-drawn graph like this. So what you should do is ignore the actual values and graph what you think the regression line would look like, getting it as close to all the points as possible. And we can notice that it looks something like this. C used the linear model in part B, right here, to estimate the chirping rate at 100 degrees Fahrenheit. So y is equal to 4.857 times 100 minus 220.97. This is the y value, the chirping rate at temperature x 100. 4.857 times 100 is 485.7 minus 220.97. This is equal to 265.73. So this is the estimated chirps per minute at 100 degrees Fahrenheit. Based off of this relation of this temperature and chirping rate function, which we can see in this graph.